Hello and welcome to my course on Applied Business Statistics. In this session, we are going to give a tutorial on methods of conducting the t-test in Microsoft Excel. In this session, we are not going to discuss the philosophy behind t-tests or the mathematical formula. Rather, we are going only to discuss how to use the Microsoft Excel sheets in order to do the calculations and to get the results and how to interpret these results and understand them. Now, in Excel, in order in order to discuss how to conduct the t-test, we should understand first that we can distinguish between different types of t-test. First, we have two independent group means and how to test whether they are different or not, and testing the paired population means whether they are different or not. Another form of the t-test is related to the population. One population mean whether it is different from the target value or not. Other form of the t-test is for one population proportion to see whether it is different from a target value, which we call it hypothesized value. The last form of the t-test is for two population proportions, whether to test them whether they are different or not. Now the details about conducting t-test are illustrated and discussed in details in my previous videos on one sample and two sample and paired sample t-tests. Now, before doing the calculations on Excel and before conducting the t-test on Excel, we should first see whether we installed the data analysis tool pack or not. We should have this tool data analysis tool pack installed first. We install it one time only on the same computer. If you install it before, that's it. You do not have to do this step. Only for one time, only once you have to do it. And if you have done it, then skip this page. So in order to check whether you installed it before or not, you should look at the Excel sheet and see this data analysis. See, if this icon is available, then you installed it before. If this icon is not available, then you did not install it before, and you should install it. In order to install it, you should follow the following steps. Click to install it. You should first click File, the File tab on the top left, left corner, the File tab. Then click Options on the left bottom corner, on the left bottom left or left bottom. Then click Add-ins. Click Add-ins. In the Manage drop-in list, choose Excel Add-ins and click Go. In the pop-up that appears, check Analysis Tool Pack. Then last thing, click OK, and that's it. You will have this icon in your Excel sheet. and that's it. You have to do it once and that's it. We explained before how to do it, but just to check, right? Then you can benefit from the data analysis programs or AdSen, right? Now, there are many available routines and many available programs in the Excel sheet now, in the data analysis tools. We are concentrating now on the t-test only. Under the t-test, you have many options. First, you look at them here. On the data analysis, if you click that the data analysis on the right hand corner, you get this pop-up, and you get one of these. All these are t-test, and also similar to the z-test is similar to t-test. So you have t-test paired to sample for means, and t-test to sample assuming equal variances, and t-test to sample assuming unequal variances. And also you have z-test, which is similar. You can use the z-test for large sample sizes also. This is for means and the proportions also. Z-test for two samples, for mean and the proportion as well. Right? So all these are the t-test, different types of t-test and z-test also. So we want to know which one to use. Now, in all two sample t-tests in Excel, the null hypothesis assumes that the two population means are equal, or sometimes the two the two population means equal one hypothetical value, like do not equal 0. The difference between the population means equal specific value. If the two population means are equal, then the difference equals 0. But it could be in some cases not 0, but we will not concentrate in this case. We will not concentrate in this case. Only we concentrate if the population means are equal. But we can in Excel still test whether the difference between the two population has specific value, hypothetical value, but we'll not talk about it here. Okay, that's the null hypothesis, which all we mentioned earlier. All null hypotheses involve equal sign. Two population means are equal, always equal here in the null hypothesis. But in the alternative hypothesis, the two population means are not equal, or it could be the first mean is greater than the second mean, or vice versa. The first mean is less than the second mean, but the equal sign always in the null hypothesis, not in the alternative hypothesis. The p-value is the most interest for us if we are using Excel. We are all mostly interested to know the p-value of the test. If we do calculation by hand, we are interested in the significance level. With that significance level, whether the t-test is computed, the t-test is significant or not according to the given significance level. But here in Excel or in computerized version of the t-test, because it is easy to calculate the p-value, the exact probability of error. So we are interested to know the exact p-value and compare it with the significance level, which is usually 5%, or in some cases 10% or 1%, but mostly it is 5%. If the p-value is less than the significance level, then we reject the null hypothesis. But if it is greater than the significance level, then we have no evidence to reject the null hypothesis. So we accept it. Now, Excel has two forms of the two sample t-test. One assumes that the variances are of the populations, because they are independent populations, and the variances could be different or could be equal or not equal. So we have two versions, a version for the equal variances and a version for not unequal variances. And all t-tests assume that the data are obtained from normally distributed populations, right? But we assume that standard deviation or variance for both groups are either equal or not equal. So, which form to use this? Usually, it is a bit more difficult to use the unequal variance case. But with Excel computation, we can still use it. And it is more safe to use unequal variances for us. If in reality they are equal, then we do not lose a lot. We do not lose a lot if we assume that the two variances are not equal, right? Which form of the t-test to use? It depends. Usually, but not using Excel and different and other statistical packages, we should do a test to test whether the variances are equal or not, but not necessarily. As I said before, it is better to always assume that the variances are not equal and conduct the test using the assumption that the variances are not equal. So it's safe and you do not lose a lot to assume that. So we agree that to use the unequal variances. Example 1. That's the most important in this session, in this tutorial. We want to learn how to use Excel, right? We assume that we have data. Data here are drawn, generated randomly. It is not real data, but we generated randomly, and assuming that there are samples of students. One sample comprises students who learn using method A, while the other sample learned using method B. So are two methods of teaching or learning, two methods. And these are the marks for the students who learned using method A, and that column is the marks for students who learned using method B, and they are independent samples because these are not the same student as those, so they are independent samples. And we want to test the means of the two groups. The method which is better, we expect that this method will give higher average or higher mean of ranks for the students than the other. If method A gave a higher mean, then will be better than method B. Method the means of method A and method B are different, then if the means are different, then the methods are different. But if the means are the same, then the methods are the same. They do not make difference. So, to perform the two sample test, we should arrange the data in this form in Excel. Two columns with two figures, with two columns of figures, right? Method A and method B. Now we want to apply the two sample t-test on these two columns, right? In order to do that, we have to follow the following steps. Go to the data analysis option here, which is in the top hand right hand corner, which we installed earlier. We installed it earlier. The data analysis tool in the right hand corner in the data tab in the Excel sheet, right? Then if you click that, then you get a pop-up for that analysis to choose from. You choose the t-test, exactly the version of two sample, assuming equal variances. Two sample assuming equal variance. As we mentioned earlier, you have different forms of t-test, but you choose the two sample assuming equal variances. You get another pop-up under input. Select the range for both variable 1 and variable 2. You click the range from the first observation to the last observation in variable, put in variable 1, and the range from the first observation to the last observation of variable 2 and put in variable 2. The hypothesized mean difference, we should put it 0 because we want to test whether the two methods are the same or not. So the difference is 0. The difference is 0. mu1 minus mu2 equals 0. So we put 0 in order to test whether mu1 equals mu2 is the same as testing mu1 minus mu2 equals 0. So the hypothesized mean difference is 0. We write 0. Right? Then, when putting the range of observations for variable 1 and variable 2, we included the labels in that range. You should check the label checkbox in order to understand that Excel understand that the first row in that column contain a label, not exactly a figure, not a real observation, but a label. If you include the label in the first row of that column, so you should click labels, but check it if you did not include the label in that range, only observations. So uncheck it. Do not click labels, right? These options make the output easier to interpret if you include the label. So you know that's method A and that's method B only if you have a label, right? The sixth step, define the alpha value, the significance level. The default value is 5%. You can change it to 1% or 10%, right? is good. Usually 5% is the best, but it is you can, according to you, up to you. You can change 5% to 1% or 10%, as you like. Change the value when you have a specific reason for doing so. Right? That's all you need. So click OK. Click OK. That's it. You finish. Then you get that before clicking OK. You get that. That's the range from A1 to A16 of variable 1. Variable 2 range from B1 to B16. Notice that we put dollar signs here in order that if you copy this range to another place, the figures or the symbols here do not change, remain the same, but they are not necessary. So this is the range here, the range observations of variable 1, and that's the range of observations of variable 2. Only you click the first observation and draw up to end and put it here, and the second here. And that's the hypothesis mean difference 0 label, because the first value is a label. Method 1 and method 2, that's label. And alpha is significance level is 5%. Then you put where to put the results, you can put it in a specific range out in the same sheet, or new worksheet, you put the name for it, or new workbook, another workbook, completely different workbook. So you should specify one of these and then we click OK. You will get these results. You will get these results. Now you can read these results easily. You have method 1 has mean 71.5 and method 2 has mean 84.7. The variance is 88.6 and 69.07 for methods A and B respectively. Observations, number of observations, 15 observations for method A and 15 observations for method B. It could be difference in independent sample t-test. Now, the pooled variances, because we under the null hypothesis, we assume that the variances are equal. So we calculate the variance or estimate the variance from the two samples. From the 30 observations, not 15 only. That we call pooled variance. Right? Hypothesized mean difference 0. Degrees of freedom is 28 and t-test is minus 4.08305. That's the t. Now we want to decide whether we have two-tailed test or two-sided test or one-tailed test or one-sided test. Actually, we want to test whether the methods are different or not, so it is two-tailed test. So we go to two-tailed test, and that's the p-value for the two-tailed test, which is 0.000336, which is very small and much smaller than the alpha level, which is 5%, as we said, alpha level. So as long as the p-value here is very small, then we can safely reject the null hypothesis and say that we have enough evidence to reject the null hypothesis. Then actually there is a difference between method A and method B, and usually because this sign is 0 is minus, then method B or method 2 is better, significantly better than method A. So we have two different method of learning. We have good evidence to say that. Right? Another example, which is paired t-test. We are going to use the paired t-test because they are paired samples. In paired sample t-test, we have one sample actually, but two readings for each observation in the sample, or other related sample. Exactly, each observation is related to another observation. Exactly. So, but here we have two dependent or paired samples. So there are 15 students or employees, and we have training course, and we have a test before and after the training course. The pre-test is the test before the training course, and post-test the test before after the training course. And we want to see whether the training course improves the skills of the workers. We want to see whether the training course significantly improves the skills of the workers. That means whether mu2 is greater than mu1, or mu1 is less than mu2. That means we have the null hypothesis, mu1 equal mu2, and the alternative hypothesis, mu1 is less than mu2. So to do that, we follow the same steps here. In Excel, we click the data analysis on the data, right? And from the data analysis pop-up, we choose the t-test paired to sample forming, paired to sample t-test. This version from the t-test paired to sample forming. Under input, you have a pop-up. Under input, select the ranges for both variables. As before, you select the ranges for both variable 1 and variable 2. Go to the range of variable 1 and select all observation and put them in variable 1 place. And go to the variable 2, we select the range from the first to the last observation and put in variable 2. The fourth step, you have the hypothesize mean difference. You will typically enter 0 because we want to test whether the means are the same or different. So mu1 minus mu2 equals 0 or greater than 0 or less than 0 actually. Right? This mean difference of 0 represent no difference between the two methods, which is no effect. Then fifth step is to click the label checkbox. If you have a label in the first row in the columns, then you check the label checkbox. Right. The sixth step is to define the alpha level, which is 5%, and you need in this case to keep it as it is. 5% is the default. If you have a reason to change it, you change it, no problem. Last thing, you click OK as everything is finished. Here the same. We enter the range of the variable 1 and the range of variable 2, and the hypothesized mean difference is 0, and check the label. Not always you check the label. If you do not enter the first value which contain the label, then you do not need to check this labels. But we included the labels here. Alpha is 5%. That's the significance level. And we check one of these and define where to put the results. Right? Then you get the results here as the same here. Now, pre-test, post-test, these are the means and these are the variances of both samples. And the number of observations 15 and 15. Pearson correlation, because we are a correlated sample here, per sample, correlated sample that measures how correlated the samples are or how paired. So that is high, then they are too much correlated. Hypothesized mean difference is 0, degrees of freedom is 14, and t statistics. That's the computed t statistic here. Minus 3.73443. And the most important thing is the p-value. The p-value. Which p-value is? It depends whether we have two tail tests or one tail test. Actually, we want to test if mu1 is less than mu2 or not. So we want to test the left hand tail test, which is the small one. So we have in this case, the p-value for less, which is equal 0.00221. This value, sorry, this one, that's one tail here, because we want to test one tail test. This one, which is so small and much smaller than 5%, which means that we reject the null hypothesis, which says no difference between means, in favor of the alternative hypothesis, which says that the average or the mean of scores for before the test is less than the mean of scores after the test. The pre-test is mean of pre-test is less than mean of post-test, which means that the training course improves the skills for the trainees. That's the final results for this example. Now we learned how to use the t-test for comparing means, and now for how to use or conduct t-test for comparing proportions. Actually, this is more bit difficult, comparing population proportions, and it is not available in Excel actually, but we can still use it using three different approaches. How to compare proportions? We can use three different approaches. The first approach is to write down the formula and calculate everything as if we are doing everything by hand, but with the help of Excel. Write the formula of the mean, variance, pooled variance, and the test statistic itself, and then the p-value, step by step, everything in detail, one step by step. That's the first approach. The second approach is, which I suggest, that if you entered your data in columns with all observation, if you have, for example, 50 observations and your data is 0 and 1, 0 and 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0, and that's it, and that's all. So, for example, if you give male 1 and female 0, or success 1, failure 0, and so on. All the data are 0 and 1, and we want to test the proportion of zeros, or the proportion of ones are different from the proportion of 0. So we can do that. In this case, I suggest that because the average will be the same as the proportion here. If you calculate the average of ones, exactly it is the same as the proportion of ones. The average of the column is exactly the same as the proportion of ones. Do that. I will show you that now. the proportion of ones is exactly the same as the average of all the column. So if you do that, then you can use exactly the same steps as before for comparing means. Your problem will be exactly the same as comparing means. The third approach is to buy one of the uh, AdSen for Excel. One is called statistician and the other is called Excel Stat. Excel Stat. You buy one of them and install it, but not necessary. So the first approach we mentioned, you calculate P hat and Z exactly here and do the calculation and until you reach the P value, and that's it. Step by step, if you have this data, zeros and ones, one column and other column all zeros and one, you do these step by step. That's P1 and P2. P1 is the percentage of ones here, and P2 is the percentage. You see that here they are sums, and P1 and P2 calculated twice, one as sums and one as proportion, which are the same here. So you calculate P1 and P2 twice with different thing. One as the first one as means, and the second one as a proportion, and continue the same, exactly the same figures you put here and here, right? Then you continue until you reach the p-value. That's the how to program these formulas, or how to write them down, right? Here are the formulas, and then you get the p-value. That's the first approach. The second approach is, as we said, is to use the t statistic. As long as you use the samples zeros and one, you use the t statistics and you get the same results. Interpret the results as they are here.